My name is Massimo Referè. I'm a principal technologist at AWS working in the container team, actually working with Nick on the stuff that he was talking about. What I would like to do in the next 45 minutes is to go through some of the concepts that we have already touched upon, maybe going a little bit deeper in some of those concepts, but mostly going through these three concepts. So first of all, I'm going to focus slightly more on ECS in this presentation, but obviously it wouldn't be an ECS presentation without touching on EKS, because as Nick was alluding to, there are lots of users out there that are asking us, how do you position those two things and those two services? So I'm going to talk about this notion of ECS being serverless and integrated, and it just works. The second dimension that I would like to touch upon is the data plane evolution. This is where I would like to go a little bit deeper into Fargate and talk a little bit more about that, among other things. And something that we haven't touched so far, which is this idea of application focus and moving a little bit away from this notion of being just a container orchestrator. So let's get into this. So we heard already some of this stuff. I'm not going to spend too much time on this, but basically, as we alluded to, Amazon is the Amazon ECS is the opinion. ECS is this opinionated way to run containers on the AWS platform, and we'll touch more about this as we go forward. Nick already alluded to this in the previous presentation, but as we talk to customers, there is this notion that a container orchestrator basically is abstracting the infrastructure, right? Because this is what Kubernetes does. However, when you think about ECS, this is not exactly what it does, right? So ECS is more part of the AWS infrastructure. And also, we define ECS as the easiest way to run containers on AWS if you know AWS. And this is exactly the point that was discussed before in terms of it doesn't really matter the size of the customer. What matters more and the most is what's your background? What do you know? And where do you want to go? To describe what I was alluding to, I usually use this slide because I think that visuals are more helpful to kind of stick a concept here. So this is a very tiny portion of all the AWS services that exist on the platform, right? I'm just listing a few of them, but there are many more. And they're always and somehow integrated through these integration service bus, if you will, right? It runs in the plumbing, right? So you do not integrate these services. This is what we do for the customer. And as Nick was alluding to, there are lots of customers that are using the AWS platform through the AWS API, right? So what the way that we like to describe ECS is that it's part of this ecosystem, right? It's just an additional brick that gets added to this ecosystem. And this is the reason for which we say that ECS is the easiest way to run containers on AWS if you already use AWS, because it uses the very same RBAC model, the very same deployment tool like CloudFormation, for example, even though you can use other tools, but it's embedded into this ecosystem, into this platform ecosystem. If you take Kubernetes and EKS specifically into the game, that is kind of where it stands, right? And this is what we were trying to communicate in the sense that there are different set of customers coming from different background, coming with different knowledge that would like to use either one set of APIs, one platform, or the other set of APIs or the other platform. And we like to think of Kubernetes and EKS in this case as a kind of empty box that basically uses Kubernetes API to consume part of this infrastructure, okay? And these integrations typically live in the user space, right? So if you want to use the application load balancer, if you want to use EBS, EFS, and all these other platform functionalities, you have to integrate this because Kubernetes by design is agnostic to the infrastructure, right? So it's this notion of simplicity versus flexibility, right? So it really caters to different type of users, with users that have different type of requirement. I would like to spend some time on that brick that you see on the right-hand side called ACK, AWS controllers for Kubernetes. So basically what this is a new open source project that we recently launched, and it's currently in beta that you can test. And what it allows users to do is, some of these users are coming in through the Kubernetes API because they know Kubernetes, they like Kubernetes, they want to use Kubernetes. However, the surface of the platform that you can consume through the Kubernetes integration that you can see on this slide is a tiny portion of the richness of the AWS platform as a whole. So if you use the AWS API, you get access to the now almost 200 services that we offer. However, if you come in through the Kubernetes API, you can only consume a fraction of those services. So the AWS controller for Kubernetes allows Kubernetes customer, Kubernetes user to use the Kubernetes API to provision services that are outside of these traditional Kubernetes integrations. Examples being DynamoDB, RDS, SQS. If you're building an application and you do not want to rebuild entirely a cloud platform inside Kubernetes, but you would like to use the Kubernetes API and use as much managed services as possible, ACK will allow you to say through the Kubernetes syntax, give me an SQS queue, give me an RDS database, give me a DynamoDB table, so that you can only focus on your application. Everything that I have discussed so far, it's orthogonal to the notion of managed services, right? Because if we move to the next visual, we manage Kubernetes for you, right? So regardless of whether Kubernetes is embedded natively into the platform like ECS or not, we manage that service. Part of the complexity that comes with the flexibility that you get with Kubernetes is coming from the fact that some of these integrations that you still see on these slides are running in user space, right? So yes, we manage EKS, the Kubernetes cluster, for you, but the problem here is that many other things that integrates with the platform are basically managed by the customer. And what I'm trying to communicate with this visual is that we understand that lots of customers want us to take more and more of this responsibility, and we want to move that yellow box more to the right and take more ownership of those user space integration that you have to manage today if you are a Kubernetes user. I also want to touch, going back to this notion of simplicity versus flexibility. And if we talk about Amazon ECS, I want to touch very briefly on this notion of serverless and versionless. Why am I saying serverless, right? It's loaded term that we keep hearing. By serverless here, I mean a secure multi-tenant control plane that we use to power the ECS service. With Kubernetes and pretty much with any other open source container orchestrator, what you do is you usually take that software, you run it on EC2 instances. It will take a while to deploy it. You can manage it yourself, or you can ask Amazon to manage it on your behalf, and that is EKS. ECS is intrinsically different in the sense that there isn't anything that we deploy when you create a cluster. Creating an ECS cluster, it's a matter of launching an API, and in a matter of seconds, you get that cluster. That cluster is nothing more than a name on the platform that you can start using. Another thing that is probably even more important, I would argue way more important, is this notion of versionless. One of the problems when you take open source software and you operationalize it on behalf of the customer, it is not possible to hide the fact that that is a piece of software, and the piece of software is version, right? So you have to move from one version to another to get new features. ECS, again, being cloud native and not being a piece of software, but being a service that we built from the ground up to be cloud native, doesn't have this notion of a version. Everything that we do when you introduce a new feature is just we roll out the feature. All ECS customers are inheriting that feature if they use ECS. And how we do this, and we have been pretty good at this so far, not just for ECS, but at large for all the other compatibility. So we make sure that everything that we roll out as the new feature doesn't break what you were doing. This is a core tenet on how you have to run a cloud service. I want to change here a little bit here, unless there isn't any question, and touch a little bit upon this notion of the data plane evolution, right? So when we talk about container orchestrator, we typically differentiate between the control plane and the data plane. Okay, the data plane is where your containers come to life. So this is where your containers consume CPU, memory, GPUs, network, and all these sorts of things. Whereas the control plane is the element that controls the deployment of these containers in the form of tasks for ECS or pods for Kubernetes. The container orchestrator does more than this. We will touch upon this, but in this session, I want to focus more on the data plane evolution and just walk you through the history of the ECS data plane expansion, as I call it in this slide. So when we launched ECS back in 2015, and we launched this new container orchestrator or control plane, we only had an option that you could use to deploy your containers. And that option that is obviously still available today, lots of customers are still using that option, is to deploy those containers on discrete EC2 instances. So basically the flow is, I create a cluster with that command that I showed you in a second. I deploy my cluster, and I'm going to define my application with ECS task, ECS services, and deploy that application on top of EC2. As Nick was alluding to before, what happened is that lots of customers came to us and they said, managing all this EC2 infrastructure to run our containers, it's just too heavy for us. We want you to take on some of this responsibility and hide in that layer for us. That is how Fargate was born. 3 years ago, we launched AWS Fargate as a serverless data plane to run containers. The way that I explain Fargate to customers is, again, through another visual that I would like to show you here. This visual has a framework. I like to talk about what we do in the context of this framework. And you can imagine the cloud being this big rectangle with this line in the middle, which basically demarcates what we do for you on your behalf and what you have to do to consume cloud services. This is the shared responsibility model that Nick was alluding to before. that line also demarcates it's the line of demarcation for compute abstraction on AWS. Think about that for a minute. If you want to use EC2, basically that demarcation line abstracts you from the physical service that you have to be able to launch an EC2 instance, which is essentially a VM. However, we never ask you to manage those physical services. If you go all the way to the right and you look at Lambda, our function as a service or serverless compute environment, where you can take a function, an application function, throw it onto the cloud and let the cloud run it. We never ask you to have visibility and manage part of the stack that runs that Lambda function. However, if you turn into the middle of this slide with EKS, ECS, and EC2, this slide this abstraction line is just theoretical. And the reason for which it is theoretical is because this is inaccurate. Historically, when you pick containers as your abstraction, because strategically you want to modernize your application, focusing on the container abstraction, that line looks like this. It's a leaking in the abstraction of a managed cloud with a shared responsibility model. We ask you to manage both containers as well as EC2 instances. And this is what customers were telling us, we want you to fix this. And Fargate is the service that fixes this. Fargate is the service that fixed this leaking in the container abstraction. As Nick was alluding to, it's not correct, in my opinion, to look at Fargate as vending machine that we manage for you. The whole idea here is that those machines are not even managed or vended to you. They just do not exist. So with ECS, when you create a cluster and you deploy 1,000 tasks on that cluster, and you switch to the EC2 instance console, you won't see any EC2 instance. They are not just managed by us. It's the whole ecosystem where this happens that is completely abstracted. Billing included. When you run your task or Kubernetes pod on top of Fargate, you're not charged for the EC2 instance that we need to run your task or pod. You are charged for the task or the pod, right? So going back to the previous slide, so not only customers told us, we want you to take over a lot of the burden of running the infrastructure, but a lot of customers are telling us, in the fullness of time, we want to move to the cloud. However, we have applications that cannot move from our data center. We like the AWS model, we like the cloud model, but the location needs to be our data center. This is where we introduce AWS Outpost. AWS Outpost is literally a piece of our infrastructure, of our region, of our availability zones that we build, and instead of shipping into a region, we ship it to a customer. The customer takes this, put it into the data center, and they will see this capacity, managed capacity by AWS, as an extension of the availability zone. As a matter of fact, when you set up an AWS Outpost, or the very first thing that you do is becomes part of an availability zone, but it remains physically under your desk. To speak, obviously. Other data plane options and AWS local zones, they are different type of managed infrastructure that we made available. Local zones are smaller regions or smaller availability zones that we are placing close to very key customers where there is demand for that to get access to cloud services with a lot lower latency. And Wavelength is, as we were alluding to before, a partnership with telco provider where we put capacity near those 5G access points.
I have a question about the outposts and how this all interoperates with the Fargate and containers and being really serverless. I mean, we use Fargate and we rely on it just basically just as the simplicity aspect. To throw a container up there, I know it's going to run. If I'm using the outposts, I kind of want that same expectation that I'm going to be on the latest hardware, the latest revision of the instance types, and be able to take advantage of new things like GPUs that may be coming. How's that even going to work with outposts? Are you going to be continually shipping and revving hardware in these outposts?
So this is a little bit of a trade-off that you need to take when you use the outpost. There are very good reasons to run your workloads in the cloud. And that is why I said before, in the fullness of time, customers want to run in the cloud. I bring up on top of what you just said, spot instances. Spot instances is something that you can technically just get out if you run in the cloud, because you're basically getting access to unused capacity with some of the trade-off that Nick alluded to. When you order an outpost, what you're basically doing is you are long leasing a piece of hardware, right? So you have to this is not really a pay-as-you-go model as you could do in the cloud. So there is a compromise here that you have to recycle that infrastructure based on your needs. So think about the outpost more as the reserve capacity, pretty much like you can reserve capacity in a region, but with somewhat more stringent requirements, because we have to ship actual capacity to you. I also want to comment, because you mentioned Fargate as well. I just want to mention that Fargate is not available on Outpost yet. And it's an interesting topic, because when we started talking about Fargate back a few months back for Outpost, because there's our obviously ongoing discussion, we thought it doesn't really make sense to have Fargate on the Outpost. Because if you pay for the pod or if you pay for the task that you deploy, how does that tie into the fact that you need to reserve that capacity? So you're basically paying for that capacity or EC2 instances in the outpost anyway. And the more that you think about this, is Fargate offers a couple of different values here. One is a trade-off on the billing side. So if you run in the region, then you can only pay for the actual pod that you deploy and the containers that you deploy or the task if you use ECS without having to reserve capacity. So that is not like a value prop on the outpost. However, lots of customers are telling us, no, what I like about Fargate is the fact that I want to get out of the business of managing AMI for my EC2 instances, which is what I would need to do on the outpost if your data plane is EC2 instances on the outpost. So there is a whole advantage that is not just strictly capacity and CapEx related to Fargate, that is more OpEx related. The amount of money that I'm saving by not having to manage that infrastructure, the AMI and everything that goes with it. The other thing that I wanted to touch on this slide is that, as you can see, there is some spare space, and we are actively reaching out to users and asking them, where do you want to run our ECS task, right? Because we have some spare space on this slide. So if you have any requirement, if you have any particular need where you want to enable ECS task on other locations, we are all ears. I want to move very quickly to the application focus, the third and last dimension that I wanted to touch upon. We discussed about this notion of the container orchestrator, right? And if you decompose a container orchestrator, what the container orchestrator does is two things. It provides a YAML interface for the user, the developer, to define their application. And the second thing that the container orchestrator does is it makes an effort to abstract and manage the infrastructure underneath. Think about ECS or even EKS, or Kubernetes in general. Twofold. It allows developers to define pods, tasks, if it's ECS, or services, or deployments, or jobs, or anything that allows you to define your application and say, go run it. The other thing that it does is it manages a bunch of EC2 instances or infrastructure capacity, right? I have these 500 containers that I need to run. Let me figure out how I can run them. What are the hosts that are available to run them? Do I need more hosts? Do I need to scale those hosts to be able to run those containers that I need to run? So it's becoming pretty clear that, and this is what customers are telling us, this abstraction that these container orchestrators are offering is way too low level, right? It's way too low level. We want to be able to deploy these applications with a very different type of abstraction and interface. The second thing that is becoming very obvious, as we discussed, is that a lot of customers are telling us this is too daunting, right? Managing the pieces underneath, scaling the cluster, scale in, scale out, managing those instances is becoming very difficult. So I'm not going to touch anymore on this notion of the infrastructure-less, for lack of a better term, because Fargate is a good example of how we're trying to fix that problem. Forget about the infrastructure. You pick the container as your abstraction to run your business. You need to forget everything that is underneath it. And that's what we're trying to do with Fargate. Let's focus more on the northbound side of this slide. I'm calling this slide the rush towards a better world. And I'm also calling out that there is a little bit of Twitter hype here, right? If you think about what happened in the last, I would say 10 years, thinking about what is the right interface for the customer to intercept the infrastructure, the right abstraction, we went through, bring your own function, bring your own repo, bring your own Docker file, bring your own image, and bring your own whatsoever, right? So we have seen this tech of the month, like pass, CAS, pass, fast, back to CAS. There isn't really a stable or golden mechanism to explore or to expose the right interface to the user. And this is one of the reasons for which I've seen a few tweets like this is too complex. And it's, as Nick was alluding to, when you have many customers with different opinions and different requirements, you have to have many tools to be able to intercept where they are and where they want to go. So I wanted to touch upon a few things that we're working on to intercept those needs. So what interface is right for you as a user, right? So there are three major things that we're trying to do, and this is very specifically for ECS. We want ECS to offer these high-order interfaces. Customers are telling us defining a CloudFormation template with tasks and deployments and this sort of thing is way too low level. We want something better than that. We want boilerplating. We also call this undifferentiated heavy lifting, right? We want to get rid of that. This is what customers are telling us. The other thing that you will see as we go through these next few slides is that For those of you that are familiar with CloudFormation is what we still use to do a lot of the deployment that you will see in a second, and a lot of the abstraction that you will see in a second. But it's kind of becoming compiled code, right? So if you need to do something new, you don't usually start, or a new application, you don't usually start by copying and pasting compiled code, right? You just start from the source code, and then eventually you recompile it. That's kind of how it works in the application world. And from an infrastructure as code perspective, this is something that we're seeing happening on the AWS cloud. So let's go through some of these examples. So once upon a time, as I said, this is what users were doing. Just writing tons of YAML to just deploy a containerized application, specifically on ECS in this case. So one of the things that we have done working with, in collaboration with Docker, is to create this integration between ECS and Docker, so that if you have a Docker Compose file, you can run that application that would otherwise run on a standard standalone Docker host on ECS. What we do is we take the Docker Compose, or actually what this integration does, it takes that Docker Compose, it compiles it in CloudFormation, and it will run the resulting model on ECS. The second thing that we have done, and there is a demo on this that Nathan is going to cover in the next session, is lots of customers were telling us, YAML is great, but I would like to use something better to describe my infrastructure, to describe my deployment. YAML isn't really a programming language, right? So it's not really infrastructure as code if you use YAML. So this is when we introduce CDK, or Cloud Development Kit. Basically, what the CDK does is it allows a user to describe the infrastructure. And this is not, let's go back to the very initial slide where ECS is just like a part of the AWS platform, right? So CDK is not just ECS. CDK is AWS as a whole. CDK allows you to define your underneath infrastructure comprised of almost 200 services using TypeScript, Python, Java, and so forth, right? Obviously, this includes ECS, but it also includes RDS, it includes DynamoDB, it includes everything that is part of the AWS infrastructure. Again, pretty much like the Docker integration, what we do here is we allow you to compile, to write that code in a native programming language, and then we compile it in CloudFormation to run and to deploy your infrastructure. The other thing, even more extreme, if you will, CLI-based, that we have been working on is this thing called Copilot. Nathan is going to show you this in a demo as well, but lots of customers were also telling us, I'm not a programmer, right? I'm not able to define my infrastructure using a programming language, right? So give me something very easy to use so that I can take, for example, my Docker file that I have and point it to that Docker file and deploy my application in production. That is what Copilot does. It basically allows the user to go through a number of steps that allows the user to define an environment, take the application, create the image, deploy the application, and monitor the logs and everything. So also day-to-day operations. Nathan is going to show you in more details what I'm alluding to here. Let's go through an example. When I started working on containers, what I tried to do was, instead of using, I'm dealing with these so many technologies, right? Because I was learning lots of different technologies. I didn't really want to go through the tutorials that each of those technologies were coming with, because that was too easy. I wanted to do what a real customer does. So I wanted to have an application, a real application or close to real life application to whom I wanted to apply those technologies. So I built this very simple application called Yelp that has a UI, an app server, it uses a database and the cache. And as I went through learning new technologies, I wanted to take this application and say, okay, how do I deploy this application using that technology? That is when I started building these artifacts, right? And this goes back to that notion of the explosion of the YAML that I was alluding to before. So the very first technology that I started learning was Docker, right? Back in the days, back in, what was it, 2014, 15. And creating a YAML file for this application, it was like 40 lines of YAML to be able to deploy this application on a Docker host. Then the next thing that I learned was Kubernetes. And to deploy on Kubernetes this application, I had to write a YAML file that was close to 200 lines. I mean, this could be optimized, but you have to define like services, deployments, pods, load balancers. It gets a little bit complex. Then I moved to AWS and I started learning ECS, Enter CloudFormation, a CloudFormation stack or template to be able to deploy the very same application was 400 lines of YAML, right? And then I switched back to CDK. And in order to be able to deploy CDK, my application using CDK, both in the context of the AWS platform, as well as in the context of Kubernetes, because one of the things that I forgot to is that we also have a version of CDK called CDK8 that basically does the same thing for Kubernetes. You write your Kubernetes artifact in Python or TypeScript, and it will generate YAML that you can apply on Kubernetes. That went back down to 100 lines, right? So as you can see, it's all about lowering that boilerplating that I was alluding to. So where does the Docker integration comes into play? The Docker integration that I was alluding to allows you and allows me as a user to take that Docker file on the right-hand side and deploy it on ECS without having to write that confirmation template on the left-hand side. That becomes compile code for me. When I deploy with the Docker integration, it gets compiled and it will be deployed. This other slide goes back to AWS Copilot. So this is the flow that most likely Nathan is going to show you in the live demo. So I'm not going to spend too much time on this, but this is a CLI-based approach where I say, initialize the environment, point to the Docker file, deploy my application, and then monitor your application using Copilot service log, for example, and stuff like that. The other thing that it does is it creates a pipeline for you so that you can leverage a pipeline for managing and maintaining that application. Going back to what we were discussing before, the simplicity versus flexibility, this over-indexes a lot on simplicity and being opinionated. Obviously, this is something that we have been working on. There is more to come, as I said. This is Reinvent season. So we're working on some other more interesting stuff to complement everything that you just saw here. So please register for Reinvent in December. I left a few links if you want to go a little bit deeper, both on the context of the data plane as well as on the context of the application first. So lots of links for the Docker Compose CLI that I was alluding to, the integration for cloud deployment, Copilot CDK, and as well as CDKs.
The process, is it pretty easy to move between ECS and EKS?
That's a great question. Well, the devil is always in the details, right? I like to say, but this usually kicks off lots of arguments, that once you have containerized your application, it's basically the YAML that we have been discussing. So the ECS YAML versus the Kubernetes YAML. I like to say that it's choreography, right? So it's I also like to joke about customers are more locked into a programming language that they have to use rather than cloud services in general, right? So without going to that extreme, I think that, so the short answer is it is possible, depending on how deep you have used the specific features of a platform. It may be more problematic to move from one to the other. I will also say that it's not just how you translate a pod to a task, or how you translate a Kubernetes deployment into an ECS service, which is kind of the counterpart. There is a lot of things that is operation related, right? It's not like the definition in the YAML, it's the platform that you know. And I want to go back to what I was discussing at the very beginning. It's just knowing a platform is what should drive your decision to use one over the other. It's not just translating the YAML file from one format to another is the first step. It may not be super difficult, but it may be it may be possible. The good thing is that if you move from ECS to EKS or from EKS to ECS, you're still running on the same platform. So lots of the operational things that you need to know are already known, right? Even though the way that Kubernetes operate is slightly different from the way that ECS operate, you get at least the majority of that covered. I'm not sure if I answered the question, but it's basically, if you want to zip it, it depends.